Dr. Jenny Bullen, who is currently a postdoctoral researcher at the University of Oxford. And she received her PhD in human development at the University of California, Davis, and was later an autism research training program postdoctoral fellow at UC Davis Mind Institute. Her work focuses on the cognitive and classroom contextual factors associated with math learning for neurodivergent children. Her previous work has focused on the experience of autistic children in the United States, but I'm very pleased to say that she's currently working with myself as well as Guy Sharif and Emily Farron, studying math learning in children with genetic conditions living in the UK. And Jenny, thank you for being here today. She's going to talk about contextual and instructional factors associated with math outcomes for neurodivergent students in the US. So Jenny, shall I give the floor to you, or if you want to try your slides? Jenny will be talking for about 40 to 45 minutes, and at the end there will be time for questions. As usual, feel free to, at that point, unmute or put your questions in the chat. Over to you, Jenny.
All right, thank you so much. Can everyone see my slides and hear me okay? Okay, great. So thank you so much for that introduction, Joe, and thank you to the Center for Educational Neuroscience for inviting me to do this talk. I am now at Oxford, but I'm going to be talking about work that I did while I was a postdoc with the UC Davis Mind Institute and in collaboration with the UC Davis School of Education. And before I continue with my talk, I want to define a couple of key terms that I'm going to be using as this research does come out of the US. And the first is Individualized Education Plan, or IEP, which is what I will be referring to this primarily as. And this is the legal document for children in public school who receive special education services. So children with a specific learning disability, or speech and language impairment, or autism, for example, might receive special education supports or services through an IEP. And the second is inclusive education or inclusive classrooms. And these are general education classrooms where children are educated together regardless of their disability, language ability, etc. This is similar to the idea of mainstream education, but the philosophy behind this is that special education is a service and not a physical space. So children are not in a special education only classroom, but they may receive pull-out instruction and services to support their needs. And the reason that I'm interested in focusing on inclusive education context is that there are approximately 7.25 million students served by the Individuals with Disability Education Act in the United States. And a majority, over half of these students spend most of their time in these general education settings. And what happens in these settings may be influenced by these overlapping forces of the environment of general education and how it's set up and who it's designed for, the different goals of teachers and their practices, and perceptions and knowledge of disability or neurodivergence. And I want to kind of explain each of these in a bit more detail. So we know that general education classrooms are historically designed for a neurotypical learner. And so they may not cater to the needs of neurodivergent or disabled students. And few states have credentialing programs that include training in both special and general education. And California, where this work was done, is not one of these states. So as a result, general education and special education training is often separate. And it creates this situation where special education teachers cannot work as a general education teacher, but general education teachers might have students who are neurodivergent or have some sort of disability in their classroom spaces. And although this is changing in a lot of areas, it's historically been the case that general education teachers have little to no training in supporting neurodivergent students, and therefore either have to seek out training opportunities for themselves or rely on their past experiences of working with neurodivergent students to guide their decision-making. And teaching also occurs in the presence of multiple competing goals. And there are these practices that are promoted that may be the best for improving educational outcomes, while others may focus on engagement or inclusion as their primary goal. So, for example, the National Council on Teaching Mathematics recommends an emphasis on mathematical sense-making, explanations, and linking mathematical representations as good practices for math learning, because all of these activities are thought to deepen the conceptual understanding of mathematics. But some research suggests that practices that maybe improve test-based performance might also be related to decreased engagement. So already there may be this tension between teachers having a goal of increasing understanding, which may be in conflict with another goal of increasing student engagement. And more generally, with this recognition that general education classrooms are neurodiverse, there's been a call for the implementation of UDL, which seeks to support learner agency and inclusivity, and also calls for practices that allow students to guide their own learning. But we do not know how teachers are really implementing these practices or if they are somehow working with or against these other goals that you might have in the classroom. But at any given moment, there are multiple frameworks and practices that teachers might be pulling from in their classrooms. And these choices overall may be influenced by perceptions of disability or neurodivergence in general. So there are several potentially damaging misconceptions about disabled students, not just limited to neurodivergence, where these students are seen as incapable of mathematical learning and thinking. And as a result, are often relegated to lower cognitive demand tasks or pull-out instruction when we know that opportunities for engaging in high cognitive demand deepen an understanding of math, even if procedural fluency isn't perfect. But the reality is that we know very little about how these children learn in general and how they learn in these general education settings. So this leaves us with some really big questions. The first is, what does math instruction even look like in these inclusive education spaces? And how does classroom instruction impact mathematical learning, especially for our neurodivergent youth? And so to answer these questions, the study that I'm going to be talking about today uses observations of classroom lessons and student achievement on a standardized math assessment to see if we can understand these relationships a bit more. And so with these data, I have two goals. The first is to try to answer that question of what is happening in these classrooms by describing the findings from these observational measures. And the second is getting at how are these observational factors impacting achievement by exploring the relationship between what we have seen in the classroom with performance on a standardized math assessment. And I just want to note that the second part of this talk is a little bit more of a work in progress, but I am going to share some of the findings that I've observed so far. So the data that I'm talking about today comes from a much larger project. The Measuring Active Participation Grant is an IES-funded 4-year grant that investigates academic development in autistic children in inclusive education. But it wasn't just limited to autistic children. In fact, 41% of the students in this study receive some sort of educational support, and many, many more are seeking a diagnosis or some sort of educational support. And in this study, we collect academic data from children, information from teacher surveys, as well as we film math and literacy lessons. But the data that I will be discussing today comes from the first time point in year 2, which was fall 2022. We had 18 participating teachers that were in the transition to kindergarten through 4th grade years. And we had 4 schools across 3 school districts, but a majority of our teachers are from a public charter school. And public charter schools have more flexibility and autonomy than non-charter public schools. We had a pretty wide range of teaching experience, with some teachers being both new to the field and new to their grade, and others have been teaching for decades. And this graph gives you an idea of the distribution of our grades. We had the most third grade classes in our study, followed by kinder and first, and less representation of TK second and fourth grade. And within these classrooms, we had a total of 108 students that participated in the study. And so for the purpose of this talk, I've divided them into an IEP and a no IEP group. The IEP group is defined as anyone that has an IEP or is in the process of evaluation for an IEP or a diagnosis outside of school. Whereas the no IEP group does not have an IEP currently, they're not suspected or flagged as having some sort of disability, and they're not in the process of seeking an evaluation for an IEP or a diagnosis outside of school. So this gives 55 students in the IEP group and 53 students in our no IEP group. The IEP group and no IEP group were similar in terms of their age, but the IEP group does have significantly lower math achievement at time 1 compared to their no IEP peers. And next, I want to walk you through our 2 observational measures that got at factors of the teacher and class. The first observational measure we used was instructional practices that was adapted from Blazer and Pollard. So we reorganized Blazer and Pollard's codes into the following 6 categories. The first looked at instructional delivery, and we looked at whether instructional moments were teacher-led or student-led. We looked at the types of participation opportunities, whether they were active, generative, or interactive. And because we're interested in math, we looked at the math instruction type, where lessons having procedural or conceptual instructional moments. Multiple means of representation looked at the use of visuals, technology, multimedia, and shared interactive documents in the classroom. And the student access to materials looked at hands-on or tactile activities, if the students themselves were using technology, if they were engaging in centers or movement as part of the lesson, or if they had opportunities for multiple methods of engagement. And then the last category looked at monitoring, responding, and providing feedback. So this was how teachers were monitoring participation, if they were giving students direct and specific praise, if they were summarizing and recasting student ideas to the group, and if they normalized mistakes and errors as part of the process of learning mathematics. And so for these videos, the math lessons ranged pretty widely, from as little as 20 minutes up to 2 hours. And the coding process was as followed. First, we identified the math activities that were included in the classroom lesson, removing the transition times. So activities were defined as tasks where the math lesson is using the same materials and covering the same math concept. So teachers in this study engaged in between 1 to 7 tasks, meaning that some teachers only engaged with one concept in one way during a lesson versus others who may have engaged in several kinds of activities or switched between the same set of activities throughout their lesson time. We then coded these activities in 1-minute intervals. So we would watch a minute of the video and then check off the codes that we saw happen during that 1-minute period. And once the videos were coded, we then sampled 12 minutes from each video across these multiple math activities. And so this was hopefully to make the observations more comparable because there was that wide range of lesson times. The second teacher or class measure that we used was the quality of classroom learning environment, or QCLE. So videos were rated using the QCLE, which is a rating system of these 3 aspects of the classroom environment. And so these aspects include differentiation, access, and individualized instruction, which rates how developmentally appropriate the instruction was for individual students. Next, we looked at classroom orientation, organization, and planning, and this had to do more with the structural factors of the classroom. What were the routines like? Were teachers using lesson plans? Did students know what tasks they were supposed to be engaging in? And then finally, we looked at warmth and responsiveness, or control and discipline. And so this rates the style of behavior management, the quality of the classroom community, and the teacher's warmth and responsiveness in communication with their students. And so these ratings were based on the full lesson length, and each area is rated on a scale of 1, which indicates poor implementation in these given areas, to 6, which indicates strong and consistent implementation in each of these 3 areas. So those were our 2 observational measures of teachers or the classroom. And for our student measures, we had 1 observational measure and 1 standardized math assessment. And for our observational measure, we used the productivity codes from the classroom measure of active engagement. And these codes indicate children's access to materials or opportunities for social participation within a lesson. And in instances of no access, students do not have access to physical materials or a social role, and so they are passively listening to lesson content. Children can also be in an open access state where teachers give students a choice of how to engage, whether with a social role or with physical materials. And then we can look at students' access to hands-on materials, which might be something like a whiteboard or manipulative. And we can look at the amount of time that they have access and are appropriately engaged with those materials versus the amount of time that they maybe have access to the materials but are not engaged or not appropriately engaged with the materials. And then we can look at the access to their social roles, which might be something like a turn and talk or a choral response. And again, we can look at how much time they have access and are appropriately engaging in their social role versus they have access, but they are not engaging or not appropriately engaging in the social role. And so these are coded as the amount of time in seconds that students spend in each state. And 15-minute samples were taken from the various mathematical tasks. And finally, we have a standardized measure of math achievement. And these were the numeration and applied problem solving subscales of the Key Math 3. So numeration involves questions that measure an understanding of rational and whole numbers with activities like counting, comparing, ordering, or identifying fractions. And applied problem solving is more verbal word problems that are presented within a context and the child's ability to use computational skills appropriately to solve that problem. And our math achievement measure is collected both in the fall, which is our time 1, and again in the spring at the end of the academic year, which is our time 2. Okay, so first I'm going to describe what we observed in each of these areas, starting with teachers' instructional practices. So there were some things that we saw all teachers engage in. All teachers engage in moments of whole class teacher-led instruction with opportunities for active participation. And they also all engaged in moments of procedurally oriented instruction. And these moments were happening quite often. So teacher-led moments were on average happening in 9 of the 12 minutes that were sampled. And this primarily looked like the teacher lecturing and controlling the pace and content of the lesson. And procedural instruction occurred on average in about 8 of the 12 minutes, though there's a lot of variability in how much procedural instruction was used. But this was primarily rote instruction and low cognitive practice and review. And active participation occurred in about 6 of the 12 minutes, and this was primarily choral responding. But there were many practices that more than half of our teachers engaged in. So most of our teachers engaged in conceptual instruction, tactile and hands-on activities. They used visuals and integrated technology within their lessons, and they monitored student participation. But we can already see that not only are these being used by slightly fewer teachers, but they're not happening as often within these lessons. So these conceptual tasks are happening on average in about 4 of the 12 minutes. And this primarily looked like mathematical sense-making activities. Other conceptual strategies, like asking children to explain or justify their answers to a problem, were very rarely used by teachers. Tactile or hands-on activities were primarily children being given whiteboards for group problem solving. Visuals and technology were often used within the classroom, and these looked like charts or posters that the teachers pointed to or referenced, as well as most of our teachers had access to a smart board and were using that for their instruction. And we also saw most teachers engage in this monitoring of student participation, which looked like walking around during independent work times. And for some, but not all teachers, this provided opportunities to provide individual support to students. But some teachers just used it as a moment to monitor participation in activities. And then there were some things that less than half of our teachers engaged in. So very few of our teachers engaged in student-led instruction, generative participation, centers in movement, or normalizing and correcting mistakes as part of math learning. And then there were a couple of things that we didn't see at all. And one was opportunities for multiple methods of engagement, and the second was interactive participation. So students often did not have opportunities to ask questions, and there are very few opportunities for students to share ideas. And I think it's easy with how I'm sort of talking about these practices to view them as mutually exclusive or opposing in some way, but really it's likely and in fact, possible that they're occurring both within a lesson context. And so we see this in some areas where teachers are using both procedural and conceptual strategies within their lesson, and very few are only using procedural. But there's kind of this imbalance in other areas where we see very few teachers that are using both teacher and student-led instruction within their lesson time. So that was overall what we saw in terms of instruction in the classroom. And next, I want to walk you through our classroom quality ratings. So when looking at classroom quality ratings, we can see that a majority of the teachers fall into these inconsistent and reasonable categories. And so for these classrooms with inconsistent ratings in these areas, we observe that tasks are not aligned to student needs. There may be an inconsistent use of lesson plans, and language is primarily directive. In classrooms with reasonable ratings, we might see that there's some differentiation in instruction occurring, but the tasks that students are doing are not completely aligned with their individual needs. There may be inefficient transitions and maybe tasks aren't always clear, but there is praise and redirection being used, but it's not always consistent. And so on the whole, this may not sound positive, but I think the positive thing is that teachers are using these practices sometimes, right? And so perhaps this is an indicator that teachers know and can implement these strategies, but maybe need supported development in these areas to be able to identify when they're using these strategies really well and moments where they maybe can use these strategies more. Okay, and now I'm going to talk about the student observational measures. And so I have presented these data as the percentage of the 15 minutes that the students spent in each state. And immediately we can see that both groups have these very large blue sections of time. And so these are times that students are spending in a no access state where they don't have access to a social role or materials and they're passively listening. And for both groups, we see that there's also a large portion of time, at least compared to other activities, that are spent engaged with physical materials. So when there are physical materials present, it looks like both of these groups are engaging in those activities. And students are spending smaller percentages of time in other states, including being engaged in social roles or having access to social and physical materials, but not engaging with these roles at all. And in these other kind of smaller slices of the pie graphs, the groups do not differ. The only significant difference was observed with the access to materials. And the no IEP group, these labels are back. Oh yeah, no, they're fine. The no IEP group spent less time in this state than students with IEPs. So the no IEP group spent about 5 minutes, 5 of the 15, without access to any materials, whereas the IEP group spent about 7 minutes without access to materials. And the no IEP group is also spending more time engaged with physical materials. So they're spending about 5 minutes of the 15 with access to materials, but the IEP group has about 3 minutes actively engaged with physical materials. And so this difference in access to physical materials and engagement is significant with a moderate effect size. This no access is exactly at a p-value of 0.05, and the effect size is really small. So it's likely that this is not a true difference. But moving forward, I would like to put these percentages in the context of the opportunities that are presented to the classroom as well. And so here's an example of what this might look like. So this is an example from one classroom. And this graph here on the left is the distribution of opportunities that are presented to the entire class. And so we can see that in this particular classroom, a majority of the time, students were expected to be in kind of that no access, passive listening state. But there were opportunities for social engagement or engagement with physical materials. But when we look at how 2 autistic children spent their lesson time, we can see that they spent even more of their time in this passive listening state. However, when the students were presented with physical materials, they were much more likely to engage in these, and a lot more for one student in particular, than these social roles. And I think that this is important because it helps us to determine if these differences in states are due to differences in what the individual children have access to, and puts it in the context of the overall classroom opportunity, right? Is this no access time due to individual students, or was there really no opportunities for engagement throughout this lesson? So just some conclusions on the observational data. So we're seeing a lot of whole class instruction that is teacher-led. We are seeing a mix of both conceptual and procedural instruction in mathematics, but there's less of a variety of conceptual techniques. And we're seeing some instructional differentiation. We're seeing some classroom organization and some responsive language with teachers, but there's an inconsistent use in some of these strategies. And overall, we're seeing a lot of passive learning with high listening demands. Okay, and this is the portion of the talk that's a little bit more preliminary. And the goal is to bring these two sources of data together to understand better what classroom factors are impacting achievement. So I'd like to share some of the initial analyses and some of my initial thoughts on what to do with this data. So intuitively, I would expect the relationship between these variables to look something like this, where engagement and classroom quality are mediating or moderating the effect of instruction on math outcomes. But the reality is that we don't know how any of this impacts math instruction. And so first, I wanted to explore if any of these factors are related to math outcomes at all. And what I'm seeing so far in some of these preliminary correlational analyses is that there are not many significant associations between the observational variables and math outcomes. So for children with IEPs, actively engaging in a social role was positively related to applied problem solving at the same time period. So perhaps this means that the students that are engaging more with these opportunities for social engagement are already better at applied problem solving. And physical access to physical materials and being engaged with these materials was negatively associated with numeration at the same time period. Right. And so being actively engaged with physical materials doesn't necessarily take into account something like accuracy. In children without IEPs, actively engaged in a social role was negatively related to problem solving in the spring, whereas aspects of the classroom structure and organization were weakly and positively correlated to numeration, both in the fall and in the spring. And responsiveness was related to numeration skills in the spring as well. And so it appears that more of the student productivity and classroom quality variables are associated with math more directly, which kind of begs the question of our instructional practices associated with engagement and quality. And in students with IEPs, teacher delivery or teacher-led instruction was negatively associated with both active social engagement and instructional differentiation. And I think that this intuitively makes some sense with the observations of the whole class lecturing. Right? These provide minimal opportunities for participations on the student's part and minimal opportunities for teachers to adapt their instruction to individual student needs. In the no IEP group, teacher-led instruction was negatively associated with engagement in a social role. But teacher-led instruction was positively associated with physical engagement. I'm not quite sure what to make of that, but I think it's possible that, just from speaking from having watched all these videos, a lot of the opportunities for physical engagement with materials is in a whole class context. So it could just be that these are maybe occurring more together. And there aren't really any opportunities for engagement in with physical materials in smaller student-led moments. And so I just want to quickly talk through some sort of next steps and ideas that I have as I'm still kind of working through all this data. And the first thing is that I want to recognize that these data are nested. So these are students that are in different classrooms, that are in different schools. And so I've begun this process of trying to parse apart these nested models, but I'm less familiar with these kinds of data. So I welcome any thoughts or helpful resources that anyone has on how to deal with this kind of nested data. But I do think it is important to note this nesting, especially as some of our schools are parts of very different systems with very different kinds of organizations of lesson plans and opportunities. And also, when looking at these types of math instruction, they've been analyzed as separate, but perhaps it's not the use of one or the other, but the teacher's ability to balance the use of both that is important. So this is getting back to this idea that teachers can move between strategies within their lesson to serve different goals. And so maybe instead of looking at conceptual and procedural instruction separately, um, the ratio of how much one is being used in comparison to the other might be more informative for analyzing how teachers are moving in between these moments. And I'm also really interested in how this may be related to growth and math skills across the school year, right? Not just the outcomes at either time point. So what aspects of teacher instruction or the classroom environment or a child's ability to engage with materials predicts their improvement in mathematics across a school year? And finally, this isn't explored in this particular study, but these are data that we collect within the larger grant. Perhaps there are child level factors, such as executive functioning or sensory processing, that interact with these aspects of the classroom environment more, and perhaps make it easier or more difficult for children to participate in these different aspects of instruction. And so looking at these in future research will probably help tell this story as well. So again, we saw a lot of whole class instruction that was led by the teacher, but we also did see evidence of many of these quote unquote good or best practices. It was just overall that we saw consistency varied in their implementation in lessons. The students with IEPs spent less time engaged with materials than their peers. And then there was kind of this question of, are they also spending more time in these passive listening states? Some more preliminary conclusions is that we did see that the predictors of math achievement were different between students with and without IEPs. And some of these findings were maybe a little bit unexpected. And so I think when thinking about this further, there's kind of this limitation that access to the materials or social roles don't take in accuracy or pace into account. So if the child is answering a question correctly, or if they're kind of answering them quickly within the period of time that they're given. And the instructional practices don't always take the quality of these practices into account, right? So we can mark off whether or not these happened, but how well teachers are engaging with these different practices is less clear. But we are seeing that teacher-led instruction impacted opportunities for social engagement in both the no IEP and IEP groups, and perhaps has some sort of effect on differentiation, at least for the no IEP group. And so again, this points to the idea that teachers know and use to an extent these good or best practices, but may need continued support in implementing these strategies. Or in professional development to understand when they could use these practices more. And a variety of teaching practices may be important for reaching both learners that have an IEP and those who do not, because the practices that were related to outcomes were not universally the same. And so these last things are maybe more limitations of this work to consider, or just general complexities within the classroom environment that I think are important to consider. And the first is that the role of behavior or classroom management in a teacher's ability or desire to implement practices, right? Maybe if providing access to a physical material really disrupts a teacher's ability to have good classroom management, then it takes away from the lesson, then we're not going to see these moments because it's taking away from instruction, even if it is a quote unquote good or best practice. And again, these student level factors like emotion regulation or sensory processing or executive functioning that may make it more difficult to engage in these different aspects of a classroom that isn't designed for students with these difficulties. And then lastly, I think this last point ties in with the point about behavior in classroom management, but how does teacher overwhelm and burnout in this post-COVID era impact teachers, again, ability or desire to implement practices or to learn new practices, and how can we support them through this unique time period that I think we're still kind of muddling through? Okay, and with that, I would like to just thank the Care Lab, our PI, Nicole Sparapani, and our co-investigators, Peter Mundy and Nancy Seng. I also want to give a very big shout out to the lab managers, undergrad students, and graduate students that were on the video assessment and coding teams, because without them, we would not have these data. And again, to our funder, the Institute of Education Sciences. And to all of you for listening. This is my contact information. And if you have any thoughts or suggestions or just want to get in touch, please feel free to email me. And I am happy to take any questions.
Thank you so much, Jenny, for a very interesting talk. So yes, does anyone have any questions for Jenny? You can either put it in the chat or otherwise, feel free to raise your hand and then you can unmute. Maybe whilst other people are still thinking, Jenny, I thought it was interesting that you found that the students with an IEP are less engaged. And I've got two questions around this. Is one, what your classrooms look like? Because of course, the US context is maybe a little bit different to the UK context. In the UK context, often students with an IEP, would have access to a teaching assistant in the classroom. And then there's a question around, is the teaching assistant maybe doing some of these activities for or with the student if you're coding? I don't know what that looks like in a US context. And secondly, whether you've got any insight in terms of why they might not be engaging so much. Is it because they might not have understood the instruction or have missed it? Like in your observations, is there any kind of inclination that you have around why that might be?
Yeah, so to answer your first question, the students who have IEPs do not always have another adult apart from the teacher that's supporting them. So this concept of a TA isn't as big in the United States. We have paraprofessionals, but typically they provide more behavioral and kind of on-task support than instructional support. That doesn't mean that they won't interfere with the child's ability to engage in a task, for example, or try to do it for them, but I don't think that their primary goal is seen as instructional support, but they're often there for kind of more behavioral management and support. And then as to why these kids are engaging less, I think it can be a lot of things. It could be this kind of context of whole class, and so it can be more confusing and distracting to know what you're supposed to do when it comes time to be with these manipulatives. But I also think that in some cases, at least with these whiteboards that we see all the time, where the kids are kind of given a problem and then they're told to answer it, and then it's okay, everyone show the answer at the same time. I think some of our students with IEPs are a little bit slower than at that. And so they they kind of can get frustrated or miss out on these opportunities because they're still working on, you know, the first problem, but we've already moved on in a lesson as a class to what has come next. So I think that kind of mismatch can be happening as well. We've also seen moments, although it doesn't appear to be showing up in the data, that the students are maybe losing access to the materials because maybe they're getting frustrated. And so then it becomes these moments of kind of conflict and behavior management with the physical materials. And then they're kind of like removed from having that experience in the lesson. So that is generally, I think, some of the things that we've seen.
Yeah, thanks for that. We've got 2 questions in the chat, if that's okay. Shall I read them out to you? Is that easiest? So Peter Mundy is asking, do you need larger samples to effectively take into account possible differences across grades, sex, and indeed there's a little bit of variability in your data. Don't know if you've got any insight into that.
I think we have a decent amount of data to investigate sex differences, although I didn't do that in this context. Grade might be a little bit more difficult just because we don't have, most of our classes, it's like 1 or 2 classes in some of the lower and higher ends, so that might not be as clear. We may be able to look at the differences between, kindergarten and 3rd grade pretty well, but I think some of the nuance might be lost there. But we do have a pretty even split of sex, I think, if I'm if I'm remembering correctly.
Right. There's another question here that says, is there any research in terms of what the ideal percentage is in a classroom when we're talking about, lecture versus active participation? Like, I don't know if you've observed any other subjects or whether you know from other subjects what should be an ideal situation.
Yeah, I don't know if I have, exact percentages that I could refer to, but I think in some of the videos that we watch where we think, wow, this is a really successful classroom, the teachers do move between these different practices more and more effortlessly. So they incorporate moments for students to kind of guide their own instruction and think deeply together about math. But then they also provide some whole class support. And maybe, provide materials so that students can continue to think about the math concept at hand. And so I think that's maybe we're kind of looking more at the balance between these different methods might give some insight into what is working for a lot of these students.
Do you think that might also, because there's still time for questions if people want to ask them, but I've got a follow-up question on that, if you don't mind, as a host, I'm going to take that opportunity, is around, do you think that it also matters around the subject that is being taught? Because I can imagine that there are certain mathematical concepts that lend themselves well to, particular materials or particular, like maybe fractions. It's useful to start with something concrete before you go abstract. But for other materials, there isn't such a kind of hands-on thing or a social opportunity, or maybe I'm wrong,
I think to an extent, yes, that's probably a correct assumption. But I think that there's also instances where maybe it's less obvious what the opportunity for using materials might be. So in the upper grades, a lot of the whole class instruction we see is working on a word problem together. And so this can often become pretty procedural because the word problem is up on their smart board. They read it together, they underline the words, they go through the steps. But there's also teachers I've seen that have found clever ways to include, what maybe don't seem like manipulatives, but are manipulative. So I know there was a class where they were trying to calculate the area of a rug, like two different rugs, and decide which one which one had the larger area. And so a teacher had cut out graph paper with the dimensions and gave it to the students to use to guide their problem solving and think about which one was actually bigger. And they were really close in dimensions, which made it, much more difficult. You couldn't just look at the two pieces of paper and say, oh, it's this one. But I think that is kind of a moment where you wouldn't think that in having a manipulative is as intuitive, but I think there are ways to include these moments in instruction.
Thank you. That gave other people time to ask more questions. I hope that's okay for you, Jenny. So we've got, do you think a fully non-IEP classroom versus a fully IEP classroom could look very different in terms of learning opportunities, but still have the same learning outcomes? So yeah, I don't know what you think about that, whether it's a problem around, inclusion, or whether, or whether it wouldn't matter if you mix people up.
Yeah. I mean, a fully IEP classroom is really special education. I don't know that there are these more general education classrooms that are fully IEP. There might be classrooms that have more kids that have IEPs and some that have less. So that would be something to investigate. But I mean, typically, I think some of the learning opportunities we see are very different in those contexts. But I think something I would like to look at moving forward is, does the number of kids with an IEP in a class kind of affect teacher instruction? And so I think that might be how we get at a little bit in terms of what learning opportunities they're giving and how that is affecting learning outcomes. I don't know if they would maybe have the same learning outcomes, though. I think that's interesting to think about.
Brilliant. Got a thumbs up from Gaia there. There is, I know it's maybe a bit too early. I know you've just recently moved to the UK, but do you think there are any findings in your study that might be US specific that might not apply, or do you think that these kind of things might apply across various countries, maybe also the UK, maybe not?
I think there is a fair bit that is US specific, right? This idea of children with an IEP maybe not having as much adult support is probably not unique to just the US, but I think from what I'm hearing in my time so far in the UK is that people know what TAs are and have seen them in classrooms. And I'm not sure there's kind of the same perceptions about paraprofessionals and what they are and what they do and what their training is. I feel like that's a bit more ambiguous. But I think these ideas around inclusion and maybe what some practices that teachers can use and how they can maybe move between different kinds of instruction could be a little bit more translatable.
Okay. I think we've got, sorry, Gaia wanted to ask a question. I'll pass on to Gaia in a minute. We've got one more question before that is, were the teachers who used more best practices, were these necessarily teachers who might have had more experience, or whether they were newer in the field, or do you have any kind of insight in terms of experience of the teachers and the practices they used?
Yeah, I haven't run these analyses yet. I think the teachers maybe that, again, this maybe isn't really measured by our scale, but that can kind of move between these moments more easily were more experienced teachers. But because we have a lot of teachers at one school in particular, a lot of these best practices seem to be kind of baked into the lesson plans that all of these classrooms were using. And so, for example, I know in the kindergarten videos, we watched like 3 of the same lesson in different classrooms. So I think some of the best practices are kind of taught or planned in. but again, kind of how well a teacher could independently do some of these things, or easily could very well be due to experience.
Um, I'll ask the final question then on Gaia's behalf, if that's okay, because we're running out of time. But what's the trade-off, you think, between the one-to-one support and inclusion?
Yeah, I mean, I think one of the big trade-offs is that it continues to put neurodivergent students with a disability in kind of a different space than their peers, and less opportunities for their peers to be interacting with individuals with disabilities, um, and opportunities for students to be teachers to one another, right? To have opportunities for peer learning. And so I think that's why we have tried to move away from fully like segregated classrooms and pull out instruction only when needed. But at the same time, we do see these opportunities for more individualized instruction that occur, but they tend to happen in reading and literacy, and not so much in math. And so it's hard to say what the trade-off for math specifically might be, because it's just not really valued in the same way I think that reading is, unfortunately.
Thank you. Sorry, I'm going to sneak in one more because I think it's an interesting question before we go, which is whether you've had the chance to look at any temporal dynamics of the instructions. And I think, pace might be a particularly interesting one because you've got videos which maybe allow you to go back and look at other factors as well.
Yeah, I haven't looked at these aspects, but I think that that's a wonderful idea and gets at some of the nuances in these different strategies that we're seeing, especially because watching them, we kind of already have intuitions about, there's a missed opportunity because the student is moving at a different pace than the lesson itself. And so I think that that might be a place to go in the future.
Brilliant. Well, Jenny, thank you very much for being here today and for presenting your research here. And thank you for all of you being here, for your questions and for listening to our talks. We'll be back again next week. And in the meantime, look out for our advertisement for the first conference for educational neuroscience in the UK. Thank you again, Jenny. Very much appreciate your insights here. And thank you all.